The quote for Chapter 3 is from Francis Crick of Watson and Crick, who discovered the structure of DNA. Almost all aspects of life are engineered at the molecular level, and without understanding molecules, we can only have a very sketchy understanding of life itself. Chapter 3, Molecules and Compounds. So elements combine with each other to form compounds, and there's 91 naturally existing elements. So, even if you just combined two different elements with each other, one atom of each, that would give you a large number of compounds. But you can have 2, 3, 4, 5 more elements in one compound, and you could have 2 atoms of one and 3 atoms of the other. You can change the numbers. And so there's this almost limitless number of compounds that are possible. They each have their own properties. So, that was...
Can you go back to the first slide so I can see the chapter?
Let's look at hydrogen, oxygen, and water. So the elements hydrogen and oxygen are very different from the compound water. What did I do? Okay. And this is very common. When elements combine to form a compound, their properties change drastically. So hydrogen and oxygen are both gases at room temperature. Their boiling points are very low, much below 0 degrees Celsius. Hydrogen is flammable. Oxygen technically is not flammable, but it is necessary for combustion and will make pretty much anything around it combustible. But you take these two gases and combine them to form water, and now we get a liquid at room temperature with a boiling point of 100 degrees Celsius. And not only is this not flammable, it's commonly used to extinguish flames. So when we have elements combining to form a compound, we've got an entirely new substance. So we've talked about mixtures and compounds before. A mixture is just elements mixed together, and the proportion could be anything, and it could change. So this balloon is an example of a mixture of hydrogen-oxygen elements. You could put more hydrogen in or put more oxygen in. You can change that ratio. In a compound, the ratio is always the same. So a glass of water here always is going to have 2 hydrogens for every 1 oxygen. And it doesn't matter where the compound was made or where it comes from, it's always going to have the same proportions.